Okay, so that last one, that was fun and a little bit interesting. Or maybe it was just interesting and a little bit of fun. Or maybe it was both. It's definitely not neither. So anyway, let's look at another one. This one is going to be similar. We're going to use one of our try substituting. Now the nice thing is that IB will very often say, use this substitution to solve this. And so they're going to kind of give you a little bit of a hint. But just so that you know, if you're thinking about this, you should notice a little bit of a pattern here. You see the a sine of theta is when it's a squared minus x squared. And if you think about your equations, when it was the derivative of the arc sine, it was a constant minus x squared. Alright, so let's go look at that again. So we go back. So constant minus x squared. So that's your a sine theta. Alright, then you got the constant and x squared being added together. So if we go back here, you'll see right there, there's your tangent, which is the constant plus x squared. Alright, and the secant is just the other one. It's the sine backwards, which you can also use cosine here. It really doesn't matter. So secant is just the opposite, where you got the x squared minus the constant. Alright, so I'm going to show you how to use this one here. So in this situation, because it is x squared minus a constant right here, we're going to go ahead and use a secant of theta. And so we're going to go integral, and we're going to say x equals, now a here is of course going to be 3 secant of theta. So we're going to need a couple of things. Number one, we're going to need to find out what dx is. So we're going to go dx d theta, which is going to be 3 times the derivative of secant of theta, which you will hopefully remember here is secant x tangent x. Alright, and so we go back here and we go secant theta tangent theta. Alright, and then we're going to go ahead and put all these in. And so for the x squared, I'm going to put 3 secant theta squared minus 9. And on the bottom for x, I'm just going to put 3 secant theta. And then for the dx, I'm going to put 3 secant theta tangent theta d theta. Alright? And so now I'm going to do a little bit of simplification. And so I'm going to go ahead and inside here, it's going to be the square root of 9. I'm going to go ahead and factor the 9 out. So it's going to be secant squared of theta minus 1 all over. Now the 3 secant theta right there is going to cancel out, which means I'm not going to have over anything. It's just going to be tangent theta d theta. Okay, now from here we're actually going to say, okay, well, I can do square root of 9, which is 3, and then I need to do secant squared minus 1. Now you may remember this from old times past. Sine squared plus cosine squared equals 1. And if I divide everything by cosine squared, cosine, C stands for cosine, sine over cosine would be tangent squared of theta, and this would be plus 1 equals 1 over cosine squared of theta, which is secant squared. Okay, and you'll see now that I've got secant squared minus 1, which is tangent theta. So that's the square root of tangent theta. And then we'll have tangent squared. Tangent of theta d theta. And it's still integral, so then we got the integral of 3. Then it'll be tangent times tangent, so tangent squared of theta d theta. Now at this point, I can actually try to figure out how to do this, but I don't know how to take the integral of tangent of theta. You may remember, so we look at our formulas. Formulas, let's see. Well, I got sine, I got cosine. what else I got? Well, looking at the integral is not so helpful. So we look at the derivatives, and we look at the derivatives, and we say, oh, look, there's secant squared. And I can take the integral of secant squared, and it'll give me tangent of x. So that's what we're going to do. So we know there's a relation between tangent and secant, and so we're just going to put it back in. So we're going to go integral of 3 times secant squared of theta minus 1 d theta. And at this point, after I rewrite, I'm going to be able to do all my integrals. Alright? So we take the integral of 3 secant squared of theta. And if you want to pull the 3 out, you can. It doesn't really matter. And I'm going to have 3 times the integral of secant squared, which remember, we just looked at that. Integral of secant squared is tangent of theta. So we go back and we go tangent of theta. And then we say minus 3 times x, so theta, and then plus c. Now at this point, it's not okay to still have the theta there. We got to put it back in. So what is theta? Well, if we look over here, well, I got x equals 3 secant theta. So what we're going to do is we're going to try to simplify this a little bit. If x equals secant of theta, that means that secant of theta equals x over 3. So if I make a little triangle over here, and I say this is theta, secant is hypotenuse over adjacent. So x is the hypotenuse, adjacent is 3, which means that this has to be the square root of x squared minus 3 squared. And so then tangent of theta is opposite over adjacent. So this is 3 times the square root of x squared minus 9 all over the adjacent, which is 3. And then I go minus 3 times theta. Now theta, I'm going to rewrite, and I could go theta equals the arc secant of x over 3, but secants are weird and so are arcs, so I don't really want to do that. So you could do it in terms of sine or cosine, but cosine would be nice because it's just a 3 over x. So I'm just going to say this equals arc cosine of adjacent over hypotenuse, which is 3 over x, just like that. And you know what? That is a pretty darn good answer. And all we have to do then is just do this last little bit of simplification. And we got the square root of x squared minus 9 minus 3 arc cosine 3 over x plus c. And you know what? We're okay with that answer right there. So, there you go. You've done an interesting integration by substitution. Watch one more, just to be sure.